In this video, we're going to be solving this problem on graphs of functions on Algebra 1 and transformations of functions. So the problem statement says the graph of y equals f of x, this function f, is shown below. How many solutions are there to the equation f of x equals f of negative x? So we have f of negative x here and f of x. So there's a relationship on the transformation of functions between the function itself and where we have a negative sign in front of the input of the function within the parentheses here. So when we have that, it means the graph of the function is reflected over the y-axis. So that's always true for any of these functions where we have a transformation like this. We have a negative sign within the parentheses. So it's reflected over the y-axis. So they're asking, how many solutions are there to this equation? Which means we need to find all of the intersection points between f of x, shown here, and the version of that graph that's reflected over the y-axis. So we need to draw the reflected graph to solve the problem. So when we have a reflection like this, instead of trying to manually figure out how to draw it, all we have to do is reverse or invert the x-coordinate. So right down here we have this point. This is -1 on the x-axis. To find the reflected version of this point over the y-axis, we can simply invert the negative sign so it becomes as +1. So this is a point on the reflected graph, something to start from. We can do the same for this up here. As you can see, the 2, this point, 0 and 2. So that's going to be -2 instead on the reflected version, but it's still going to be at the same y-coordinate, which means just go along here. It's going to be up here instead. That's the reflected version. We do the same for over here, x equals 4. So then we have the same y-axis level here, and we go over 4 to the left from the y-axis. So it becomes this point. So we have some information now on this graph. We can use one more point. We've got a 1 over here. This point over here has a 1 on the x-axis. We can put that right over here. So now we have a lot of information about this graph. So we have a lot to go on here. So we can really and quite easily figure out how to work this out. There's also, we can just draw a line straight through this graph, connecting all of the dots here. Okay, and then from here, you might not even need to go through and fill in any more points. You could do the -2, this point here, and you could put it over here, or you could just look at it and fill in the line. So that would give you this. So that's our reflected graph there in the black. So that's the reflected version of the graph. That's f of -x. And they want to know the solution. So we need to find the intersections. And the intersections for this graph, you can see there are 3. Got the first one right here, touch. The second one here. And the third one over there. Now, they didn't ask for the specific coordinates of these solutions, just they want to know how many there are, and here we found 3. So there we have it, 3 solutions to the equation f of x equals f of -x. Okay, that's how you would solve a simple function problem like that. All you have to do is recognize the transformation of functions there. You have a negative sign within the function definition in front of the input. That means you're going to have a reflection over the y-axis. Then just invert the x-coordinate. -1 becomes 1, -3 becomes 3, and you trace in that new graph and find the point of intersection to get your solutions. And that's how you would solve that transformation of functions problem on Algebra 1.